want to start now or waiting until 100? Two more, see?
Okay.
Let's start now, bro.
Go ahead.
Okay,
Okay,
99.
go ahead. Okay. Rachel,
Okay.
go ahead.
Rachel?
Yep.
Rachel? Yeah.
Okay. Good morning, everyone. We're delighted to welcome you to Wonderful Indonesia and Korea 2020 webinar series. So last year on the 10th and 11th of October 2019, we actually held a seminar in BINUS FX regarding the fourth industrial revolution. This year, however, due to the pandemic, the series of WINC will be held through this online conference. This is precisely why in this year's webinar, we will discuss COVID-19 treatment and prevention in Indonesia based on ICT services. This is especially important to those from IT backgrounds like me, and I'm pretty sure most of you as well, who can contribute to mitigating the pandemic in Indonesia. So it is my privilege to introduce and welcome Pak Wince, the Dean of Faculty of Computing and Media of BINUS University International, Pak Fergianto Gunawan, the Head and Master of Industrial Engineer in BINUS University, Pak Raymond Bahana, the Head of Program of CS in BINUS University International, Professor Daniel Min, Professor Choho Kang, Professor Kim Jae-sok from Yonsei University, Professor Lim Shin-il from Sokyong University, Professor Kim Nam-yong from Kwangun University. Last but not least, welcome all participants to Wonderful Indonesia and Korea webinar. We hope that you enjoy the discussions we will have today. So we would like to start this webinar with a welcoming speech delivered by the Dean of Faculty of Computing and Media. Please welcome Pak Wince.
So yeah, okay, Rachel, he's not coming.
He's
so
not
he has
here.
class.
Oh, I'm sorry. Okay.
So I will replace
okay,
him. So,
Pak Raymond. Okay.
It's okay. Thank you so much, Rachel. So yeah, thank you everybody. It's already 102 participants. So Prof Kang, yeah, it's already more than 100, Prof. So yeah, thank you so much to join this event. This is the fourth time we have this event. Of course, first of all, I want to thank Prof Daniel Min and Prof Choho Kang, that initiate this event 4 years ago, and we still have it 4 times already. Thank you so much, Prof Daniel and Prof Kang, for this for this event. Okay, this Wonderful Indonesia and Korea. This year we collaborate with the Master of Industrial Engineering program. Thank you, Pak Fergianto Gunawan, to join us to help this event. Also, I want to thank all 4 speakers, Professor Jae-sok Kim from Yonsei University, Prof. Selin Im from Sept University, Prof. Nam-yong or Prof. Steve Kim from Kwangun University, and the last one, Pak Fuad Hasahid Lalayan from Accenture, Indonesia. So for the student, yeah, this is your chance to have a workshop or seminar with a professor from overseas. This for people is very good in their field. So I hope you will get more information and we can discuss a lot with them. So after they give a presentation, please also ask some question if you want to know more detail about the material. Okay, so I also want to thank for Jude Martinez. Jude, thank you to help this event for 4th time. Unfortunately, this year in online, online is better if we can meet in the FX use, like 3 years ago, the past 3 events. So again, thank you so much to join this event. Thank you for all the speakers. Thank you to Prof Kang and Prof Daniel Min. And Rachel, I give it back to you.
All right. We're going to continue to Professor Daniel Min.
Professor Pak Fergianto first.
Pak Fergianto, okay. We're going to hear a welcoming speech from Pak Fergianto Gunawan, the Head Master of Industrial Engineering.
Thank you so much. Thank you, Rachel. Good morning, ladies and gentlemen. Thank you for participating in this event, WINC 2020 or Wonderful Indonesia and Korea. I like this name, Wonderful Indonesia and Korea. Excellent one. As you know, this year theme is COVID-19 treatment and prevention in Indonesia based on ICT services. Clearly, the theme is relevant with the present conditions where COVID-19 has disrupted the way we run our businesses, and dependency on ICT services become ubiquitous, omnipresent. Now all things relies heavily on ICT. With the event, I wish that all of us to have an excellent discussions and acquire a new insight and able to go through this hard time with an excellent performance. And finally, I thanks for all the speakers and let us enjoy the discussion. Thank you so much.
Thank you. Terima kasih.
Terima kasih, Prof.
Yeah. Okay.
All right.
Raquel.
Yeah, thank you, Pak Ferianto. We're going to continue to Professor Daniel Min. Professor Min, 안녕하세요. 만나서 반갑습니다. Professor Min is currently the president of Songhwa IPO, a director in SWIMS, EATS, and a lecturer of MIS in Korea University. But more importantly, he is one of the founders of Wonderful Indonesia and Korea. So we're delighted to welcome you, Professor Min, to share us the WINK Foundation concept.
All right, thank you. Congratulations on first anniversary. And there was a time that before WINK Forum, and there was now it's after WINK Forum. What will be the difference before and after? Somebody can answer. What is difference before WINK Forum and after WINK Forum? Okay, the answer is before WINK Forum, there was Wonderful Indonesia. After WINK Forum, there is Wonderful Indonesia and Korea. So Indonesia is becoming the blessings to Korea. Thank you for Indonesia. When I visited Indonesia, I found that Indonesia is very wonderful, wonderful people and the nature. And so I was impressed. So that's why WINK Forum started. Second point, we are building the wonderful community together, and the students are the heroes. Students are wonderful builders, and the staffs, professors, we are helping them to be a wonderful WINK leaders later. And we appreciate many professors, Kosala, Professor Kang, and Raymond Bahan, you are head of this program, and God showed many amazing progresses. There was not just the WINK Forum, but ICT class came, and many professors from Korea and the industry president participate in the course, made it together, and finally, that God started this WINK Forum, and this WINK Forum will be a blessing to convey blessings to all the earth. That's what I believe. So next year, maybe this forum with 700 people. Not just the 1 year it is event, but from today to next year, it will be a continuing relationship between students, between Korea and Indonesia, students and professors. I hope that it can be a continuing and the progressive relationships, day by day. And I will bless all of you who are participating and praying and helping WINK Forum. And I really appreciate all the steps of BINUS, that I found out that BINUS is very dynamic and very kind, the steps and the people. And you are wonderful BINUS, universities, and you are the blessings to Indonesia and to Korea. Thank you.
Thank you. Thank you. 고맙습니다.
Thank you, Professor Min, for the explanation. I will now hand the next part of this webinar over to Mr. Jude Martinez.
Okay, so good morning, everyone. Thank you, Rachel. As what Raymond and Prof. Kang and Daniel Min already mentioned, yeah, this is actually our 4th year and we're doing it for the first time online. I'd like to reiterate that we will be conducting this webinar series in 2 days. We'll be expecting 2 speakers today. The first one is Professor Jason Kim with his topic, how to overcome COVID-19 situation in IT. And afterwards, we have Professor Shinil Lim, which will be, he'll be delivering bioelectronic technologies for increasing the quality of life. And for tomorrow, we also start at the same time at 9 a.m. We'll be expecting Professor Namyong Steve Kim to deliver a talk on the trends and challenges in research on COVID-19 detection at point of care test, POCT as they call it. And lastly, we have Mr. Fuad Said Lalian from Accenture Indonesia to deliver a talk as well. So I just like to remind that for each talk, the participants are required to register. We'll be giving the links. The first link is already on the chat box, and the corresponding links will actually be shared a little bit later when the second speaker starts. Okay, I guess with that, good luck and enjoy the show. Thanks, Rachel.
Yeah, thank you, Park Jude. Okay. Okay. Okay, Rachel, go on. Go ahead.
Okay. We shall now start with our first talk of the day, Professor Kim Jae-suk. 안녕하세요. Professor Kim.
Okay. Go
안녕하세요.
ahead.
Good, sir.
지금 학생들 118명이 들어와 있어요, 지금 현재. 학생들한테 안녕하세요 좀 하세요, 지금.
Yeah, hello everyone. So, may I start?
Yes, Prof, you can start.
Okay. Well, here, let me, okay. Oops. Okay, I'm so glad to present my special lecture today at a WINC conference. Actually, last October, I gave my lecture at the classroom of your BINUS University, but this year, it is sad to be giving this lecture online because of COVID situation. However, today's my lecture is about how to overcome COVID using ICT technology in Korea. So I think it is good to use online technology for this lecture. So I hope our experience using ICT technology to overcome COVID will help you to solve the difficulties of your country's COVID situation. Okay, now let's start my lecture. So I will cover these topics today. First, I'll make a brief review about starting and the current COVID situation. And then I'll present the application method of ICT technology by grouping them into 3 categories: the prevention plans, infected person tracking and tracing method, and AI-based COVID treatment and vaccine developments. And then I'll talk about some new laws related COVID, followed by concluding remarks. Okay, as you know, the COVID-19 started on December 1st last year in Wuhan, China. It occurred in Korea on January 20th this year by the woman returned from Wuhan city. And it started in Indonesia on March 2nd this year to 2 women contact with infected Malaysian. Is that right? Well, this map shows the global early spread of COVID-19 on February 17. At this time, the total number of infected people is about 71,000 something. Okay, and 99% occurred in China at this time, and then Japan, Singapore, then Korea was about 30 infected cases, but not yet in your country at this time. From mid-February, I don't know why this is, let me pencil. Okay, pen. Okay, now. Okay, from mid-February to mid-March, the spread in our country was very large. This one. It increased from about 30 to 10,000 for 1 month period. But Korea began to slow down because of our effective activities, which I introduced today. However, mid-March, the spread in Europe and United States began to increase rapidly, like this. And still, these countries continue to have a huge increase in infected people. On July 1st, UN report mentioned that Korea is the country with the best initial effective response to the COVID crisis among OECD countries. Okay, this one shows the early spread of COVID in Korea and also our early actions. On February 19, one confirmed patient in Daegu City traveled to several places for a week without wearing mask. So it became the starting point of tremendous spread in Korea. At the beginning of March, we started limited sales of masks and also starting running of tracking system using ICT technology. So I'll explain this one later. The second half of March, we started a social distance policy, which keeps at least 2 meters away from others. And then we also started 2 weeks mandatory quarantine for all inbound travelers. This slide shows the worldwide COVID status on this Monday. USA ranked the first with 8 million confirmed cases with 220,000 deaths. India is more than 7 million confirmed. Next is Brazil, Russia, Colombia, Spain. But your country has about 336,000 confirmed cases with a little bit about 11,000 deaths. Our country now has 24,000 confirmed cases with 434 deaths. The official total number of confirmed cases is about 38 million with 1 million deaths. However, last week, WHO announced that they estimate more than 20 times as 760 million people infected worldwide. That means it is about 10% of world population. This line shows the daily increase of COVID on October 12th. India shows the increase of 69,000 confirmed case on single day. It accounts for about 20% ratio of the total number. USA is about 42,000, Brazil 34,000, Spain, England, France is more than 10,000. But your country is about 3,000 or 4,000 confirmed case. But our country has about 97 people, and we had a double-digit increase every day over the last 2 weeks. So this tells that our quarantine activities is very effective in reducing the number of infected people. Well, Wall Street Journal posts an article on September 25th with the title of How South Korea Successfully Managed Coronavirus. It says that as soon as the COVID spread, Korea quickly developed a test kit. When an infection occurred in a region, text notification was sent to the local citizens with a hyper-connected communication system. When the supply of masks was short in the early days of crisis, the government took the lead in the managing mask production, something like that. So in conclusion, they mentioned that Korea is the only country in the world to solve both quarantine and economy in the COVID virus crisis. Okay, I think this is due to the quarantine activities utilizing the Korea's top-level ICT technology and their internet users. So I'd like to show some statistics of the internet user and smartphone users in Korea. Our population is about 50 million. Internet user is about 92%. Smartphone user is about 90%. That means, except for children, all Koreans are connected to the internet using smartphone. Well, as online search channel, Korean prefer the Naver, which is a Korean-made search engine than the Google. Even on the social media, most Korean also use Kakao, which is made in Korea. We also launched the world's first 5G network service last year. So our government actually used these kind of our ICT environments for developing some prevention plan and also some tracking systems. Okay, the first category of ICT technology is the COVID prevention plans. So I would like to present this one as 8 items. The first one is code of conduct and how to act when you have symptoms. Second one is open COVID information website. Third one is a mask distribution management system. Next one is a smart fever checking visitors using QR code, self-quarantine safety protection app, online education platform, and the smart working platform. Well, in the early stage of COVID situation, our CDC, which is a Center for Disease Control Office, prepared the code of conduct and a guideline on how to act when you have symptoms. Then they made this one as posters and distribute to all institutes and residences. And then we asked to put them on the walls and in the elevators. Cities also broadcast these contents several times every hour on major TV channels with two languages, Korean and English, on the bottom line of the screen. This is a sample of poster for code of conduct. So this one includes a picture with some short description for each rule. It's in Korean now. This is an English translation of the previous one. Wash your hand with soap frequently for more than 30 seconds. Do not touch your eye, nose, and mouth with unwashed hand. Wear a mask whenever you go out. Cover your mouth with sleeve or tissue when coughing. Reduce visit to place where many people gather. Maintain arm gaps, which is 2 meters between people, which is called social distance. And avoid contact with people having fever or respiratory symptoms. This is another poster for guideline how to act when you have symptoms. This is an English translation of the previous one. So when you have some of following symptoms, such as fever, cough, sore throat, or body ache, wear a mask always and avoid contact with others. Stay at home for at least 3 days while taking a good rest. Call 1339, which is a city's call center, before visiting a hospital or emergency. Use your own car when you visit the screening place. Report if you have contact someone with similar symptoms. Report contacts and visiting place in past 5 days if COVID test result prove positive, and follow the directions of medical steps. The second action was the opening official COVID information website for providing some COVID related information. This site contains the information about some statistics, code of conduct, how to act, location of examination center, and information about the infected person's movement. However, as the number of infected persons increased, this item number 5 moved to each local district website. This one shows the main page of this website. Oops. Okay, each local government and district provide a similar website. It contains the additional detailed information about the infected person movement within each district. Something like movement route, place of time of stay, transportation uses information from 5 days before the date of positive result. And then local district office send a text message to people in the same district. So it contains some outbreak news and related site information of infected person in each local area with the infected person number assigned. Any emergency announcement for preventing COVID-19. This one is a sample text message. which is saying that Gumcheon district 91st confirmed case occurred. Please refer below URL for detailed information. So when you click this URL address, then you can see that some detailed movement line of this infected person. Something like June 26 from 9 to 12 stayed in the office, 12 to 1, so visit the restaurant A, 1 to 2 p.m. is use bus number 388, something like that. The next one is a mask distribution system. In the early days of COVID, which is February and March, the face mask supply was not enough. So we had to stand in the long line to buy the mask because each pharmacy was supplied only 200 masks per day, and each person can buy only 2 masks at a time. So government developed a special software quickly for managing evenly distribution of face masks and used in pharmacies from March 9. Each person can only buy 5 masks per week on their designated days, according to the last digit of the year of birth. The software checked each person's purchase of the mask and also restricted the mask parcels to foreign countries. However, at the beginning of July, the system was shut down because we got enough supply of masks. Next one is a smart fever checking. Whenever you enter a building or store, the following 3 checks are required: face mask, fever checking, and recording of visitor list. For checking the fever, we installed the smart fever checker in every public places, like subway entrance, bus entrance, building entrance, school academic entrance, even in the restaurant, cafe, or church. Then automatic alarm will sound if it detects someone with a temperature of 37.5 degrees or higher. We also installed this one at immigration gate in the airport for checking the body temperature of inbound travelers. This is a regular thermometer, which is used at some restaurant or cafe. This is a smart fever checker at the subway entrance. This is another one at the bus entrance. This is a picture of me taking my temperature at the entrance of my office building. The next one is checking visitors using QR code. Each building and store must make a visitor list. There are 2 ways to create an electronic access list of visitors using QR code. The first way is to create personal QR code and check it on the entrance code reader. So you select the QR check-in menu at the Neighbor or Kakao app. At this time, you must use your own mobile phone. And then you read the personal information consent guide and click the agreement button. Then one-time QR code is generated like this. And then you have to check it on the entrance code reader like this. The second way is to check the QR code of each building or store with a special app. The people must download Access Safety Confirmation app. Then the people recognize the QR code of the building or store at its entrance using this app. So something like this. So when recognition is complete, you must click the confirmation of consent to personal information, and then you will get this kind of confirmation screen window. So you have to show this one to the entrance inspector. If this is not available, then each business unit must make a visitor list on the paper. The visitor information obtained in this way is used to trace the close contact person with the infected person later. The next one is self-quarantine safety protection app. Self-quarantine is required for two cases. The first one is all international arrivals must have self-isolated for 14 days. They are not allowed to go out from the designated place, which is own home or government-provided facilities. The second case is the people in close contact with the infected person, like eating together, talking together, living together, meeting together. In this case, they must stay at own home for 14 days. But in this case, they must download this protection app. This app supports the monitoring of those people under self-quarantine. So this app is used to monitor their conditions and conduct self-diagnosis and ensure that self-quarantine orders are kept by setting the alarm and notifying to the case officer when the person leaves the designated quarantine place. It's about 10 meters wide. It is also used to report the quarantine person's self-diagnosed information on the daily basis, like any symptom and body temperature. This is a sample screen of this app. So self-quarantine safety protection app. Then you have to register your quarantine location when you arrive at the designated place. We also provide a self-diagnosis mobile app called App Self-Check-It. This one is to develop to monitor symptoms of inbound travelers every day. And it also provides user-friendly medical services. This is the main screen of this app. Okay, every school nationwide starting online classes the whole year. I know your country is also doing the same way for education. But we support online classrooms with various online platforms. You know, there are two ways, one way or bi-directional. So EBS, eStudy Room, Class Team, Google Classroom, Zoom, Google Meet, something like that. Our government also support the free IT devices for studying to low-income students. This graph on the left side shows the number of users for each education platform. So Class Team, Zoom, and the Classroom at the top level. Right-hand side graph shows the total usage time for each platform. So it also, shows that Zoom, Class Team, Classroom are on the top list. The next one is a smart working platform. The office workers are working through ICT-based online meeting platform. So this one eliminates the need for physical contact between participants. So our government provide the guideline to work at home using Korea's ICT infrastructure. So they recommend companies to have 1/3 of workers to work at home. So we also support the cybersecurity guideline for staff working remotely. Well, here is 2 examples for platforms. Neighbor, which is a Korea ICT company, provide a free remote working platform called LineWorks for small and medium-sized business. It supports the most functions required for company work, such as a schedule sharing, team meeting, or video conference. Kakao, which is another Korea messenger company, provide a work platform, Kakao Work, which is developed by using the Kakao interface that most Koreans use. We also provide a remote medicare system, which permit the doctors to perform telemedicine to avoid the group contagion in vulnerable facilities. It supports the phone consultations and any prescribed medicine. We also launch a mobile application for remote diagnosis called Coronavirus 119 app. Okay, the next category shows the important things to overcome the COVID. Infected persons tracking and tracing using ICT. First one is a screening test. Second one is a movement tracking system based on the big data. Third one is a contact tracing for infected person. If someone has suspicious symptoms and suspect COVID, they should get the consultation from 1339 call center first, then visit a screening center. Government provide a list of screening center on CDC website. If the test result is positive, the person with a severe symptom is transferred to the hospital. The person with mild symptom is transferred to an isolation facility. The CDC officer investigate the infected person's past 5 days movement in detail and make a list of person he or she met. This data is used to find out where and from whom it has spread, and also used to find and inspect close contact persons. The second method is a movement tracking system. This system is developed to find out all movement of infected persons using detailed questionnaire data with infected person and big data information such as credit card usage history, public transportation card uses, smartphone location history, and the CCTV satellite. The left picture shows the location of the infected person with the number assigned in a specific area. The right-hand side shows the movement of the specified infected person as a graph, something like this, okay? After finding this kind of movement information, we take 3 actions as follows. The first one is this information is uploaded on the local district website. However, this information is only valid for 14 days to protect the personal information. The second one is to send a text message to people near the contact line for last 5 days and to residents in the same district. The final one is very important. We send a text message to people who are in the same place at the same time period, which is about 30 minutes, to get a COVID test. We also notify to person in the close contact for taking a test by phone. This is a sample text message from local district to people in the same district. Okay, Mapogu district, number 56 confirmed case occurred. Please check the below address for detailed information. So when you click this one, you can see the detailed movement information for this person on some each day and time with some location. And then we send a text message to people whose movement line overlap with the infected person to get a COVID test, screening test. So this one is like an infected person's movement line, something like this. Okay, then send a text message to people, something like your movement on June 9, 3 p.m. overlapped with Jongno-gu number 120 infected person. Please check it and let us know if it is right. So that means government access the everybody's movement using their smartphone. So using all of this method, we isolated to the infected person and also prevent further spread by finding the close contact person to take a screen test. The next category is about the AI-based COVID treatment and vaccine developments. There are 3 items in this category. The first one is AI-based diagnosis kit development. Second one is therapeutic drug development. Third one is a vaccine development. In 2015, MERS virus pandemic, we create a white paper, which is a guideline to combat the infectious disease. We also experienced the utilizing of RT-PCR test equipment to diagnose infectious disease. And it was based to develop COVID diagnosis kit quickly. Pharmaceutical companies collect AI-based genetic big data information to develop the diagnosis kit. They used AI technology and supercomputer to improve the accuracy of the diagnosis kit. So they supplied this diagnosis kit from March, and currently we are exporting this kit to more than 150 countries around the world. During the first half of this year, the diagnosis kit exports increased more than 13 times over the same period of the last year. Now it has increased much more. But these are the diagnosis kit export samples, something like that. Okay, the second issue is the therapeutic drug developments. in general, it takes at least 5 years to develop the new drug candidates and takes another 3 to 5 years for conducting clinical tests. That means we have to wait almost 10 years. However, AI program to find the COVID treatment candidates enable the development of new therapeutic drug candidates within 6 months. It can also shorten the clinical test up to 6 months. That means it will take around 1 year. So we expect maybe next spring time, if it is successful. There are 2 ways to develop this drug. The first one is that to use AI deep learning technology to search for treatment that have the closest molecular structure to COVID-19 among existing antiviral drugs and use them for COVID treatment. This is now under treatment. The second one is to use AI program to find the compound structure that blocks virus protein by trying to synthesize various compounds. The first method starts by analyzing the commercially available antiviral drugs using drug protein interaction prediction AI algorithm to determine whether they are applicable to COVID virus. And then it continued to learn the information of all antiviral drugs by designating the ability to bind to viruses as an evaluation index. And finally, it performs the validation of actual effectiveness through clinical tests. The second method uses AI program to find the compound structure. First, AI program learn about 1 million compounds very quickly. And then it create 100 hypothetical compounds each time and check if they match the desired properties of candidate. After this, it repeats this trial to find the structure of compound that blocks the protein of the COVID virus. And finally, as designed by the AI program, robot or 3D printer chemically combine the therapeutic drug. Well, here is the 2 examples. The first one is Diogen, which is a Korea AI drug development company. They use AI technology to predict the effectiveness of COVID treatment of existing drug. Another company, JLK or BINUS, they use AI medical image diagnosis or chest CT to reduce the test time to 20 seconds. The third topic, which we are really waiting for, is vaccine developments. AI program analyze the property of a large number of pharmaceutical compounds, search for RNA suitable for antibody properties, and conduct experiments. Okay, the first step is to analyze antibody characteristics in the blood of the existing COVID patient. Based on extensive analysis data, the RNA structure suitable for antibody characteristic is searched. And then Human cell read this RNA to make viral protein antigen. The next step is to cause the body's immune system to make antibodies against this antigen. Before clinical test, AI analyzed the human reactions and results through various simulations. When the practical clinical tests are conducted, analysis of clinical outcomes and responses are performed. As you know, clinical tests must go through at least 3 stages. It also provides a visualization of result data to make judgment quickly. If the vaccine development is successful without other side effects, we expect the vaccine to be developed in the middle of next year and take 1 or 2 years to complete the vaccination for most people thereafter. In order to carry out these quarantine activities in efficient way, appropriate laws have been revised. The first one is to add new definition of suspected infectious disease. We also made some revisions for the basis for quarantine and checking of symptoms using ICT technology for suspected person. It also provides some basis for using equipment such as information devices, image information processing devices, and electronic detectors for quarantine. However, their personal information is only used for tracking of infected person. Government is not allowed to use this data for other purpose. One important item is that penalties for violating this quarantine. $10,000 or 1 year in prison. Another penalty is that if infected person make a false statement and interferes quarantine activities, maximum penalty is about $20,000 or 2 years in prison. It's very strong. Well, our country established several measures to overcome COVID-19 using ICT technology. So far, this method have proved very effective to overcome the COVID virus situation in our country. Through all of these activities, we have learned that ICT technology helped prevent COVID-19, including quarantine. ICT helped find and trace quickly for infected person and the contact person. AI technology is usefully utilized in development of COVID treatments and vaccine. It can reduce this development period from 10 years to 1 year. I hope that Indonesia also apply this kind of ICT technology well and overcome COVID-19 quickly. However, even if we create a variety of quarantine systems like this, they are useless if people do not follow them. Most of Koreans follow the government recommendations and regulations well. This is another part of Korea's successful quarantine status. As you know, America and Europe have a problem with this aspect. They don't want to wear a mask. They don't want to get some limitation of their movement. They don't want to provide their information about their movement, something like that. Okay, now I'd like to state my last word. We must do our best to turn this crisis into opportunity for the world to pursue peace and happiness together as one community. We are the one world. So I hope to see you all face to face after COVID is quickly over. Maybe next year or the year after next year. Terima kasih. Thank you.
All right, thank you, Professor Kim Jae-suk, for the talk. It's actually really frightening, to say the least, about the amount of cases there are worldwide. So it's very important that there's a prevention plan.
Yep.
And it's also quite amazing to know that AI programs can develop vaccines. So we're now going to have a Q&A session with Professor Kim Jae-suk. If anybody has any questions, turn on your audio and video or type your question in the chat box.
Okay. 안녕하세요. Okay. Any questions is okay. Hi. Any students, any chance? Open your audio mic and question to the Professor Kim. How to apply this topic to Indonesia? Okay.
Well, actually,
Good morning.
okay.
Good morning.
Daisy.
May I ask question?
Yep, sure.
Yeah, my name is Daisy. Yeah. Thank you, Professor Kim, for your outstanding presentation. I really appreciate that. So I'm sure that everyone here gets a lot of information and the updating from you about Korean, how Korean beats this COVID-19, especially the government and the educators and business sectors there in South Korea. So I heard a lot of news and watch TV and YouTube and updating about how Korean, especially the government, overcome this such of case, not only in Korea but also around the world currently. And my question is that based on my point of view about Korea, how a lot of people there really follow the rules from the government, and if we compare it with here in Indonesia, I mean, it's about the need and it's about the what's that? It's like people like follow the rules. Like everyone has to follow the rules, right? So that we can overcome that. It depends on us actually. But the great thing is that in Korea, there are you guys like really concerned about technology. Yeah, that's the system that you use and the application that you use. That Indonesia also has to learn more about that, especially. And I heard about the bracelet. Is it right, Prof. Kim? I likely use that to signaling. I mean, I watched and I read that from the newspaper online news that Korea used that kind of term. And from the first outbreak, Korea really worked really fast to overcome this kind of situation. And my question is that why you guys really concerned about technology to one of the systems that you use to overcome this? The secondly is that how you guys treat your society, I mean the people there in Korea, so that they follow the rules. So we as Indonesians, especially the students here, because I'm a lecturer at BINUS Bandung, in my class also, I really concerned about, guys, please, the students, you are the youngest, please follow the rules. Yeah, because it's really hard for us, like outside my neighbors, to talk about my family. It's really, really hard for us to talk to them to wear masks. to follow the government regulation, sorry, and how you guys concerned about it, and perhaps you can tell us the tips, and me as the educator will follow what you do. And even though only in front of my students, I can spread the message. I can tell them how about guys, please, especially for the computer science students, because I also concerned about my students at the department, because I'm an English lecturer there, and I want to ask them, like, you have the knowledge about IT. So this is one of the things that you can do for you guys, like about applications, so they can work together with the lecturer in a department's computer science department to help Indonesia example. So we can learn from you in Korea. I think that's all for my question and my statement about this. And I really, really concerned about it, especially as an educator. Thank you so much, Professor Kim, for your presentation. And I hope that you can answer my questions. Thank you.
Okay.
and the other professor and the other, like Mr. Kang and other and Mr. Sinil. I'm still learning Korean, to be honest. Sorry for my pronunciation. Thank you.
Thank you very much for your questions and concerning. And so
Yeah,
your
sure.
very long, so Prof. Kim will answer to the point of view. Okay.
Okay. Let me tell you about some second issue. Most of Korean cares their health very seriously. That's the basic base to follow the rule. So they are concerned about their health condition very deeply, seriously. So they want to get some any guideline from the government, then they really want to follow that. That's the one real base. Okay.
Yeah.
So when you say to the students, this guideline is for your own health. Okay, that's the first. The second one is you have responsibility for society. So that means you don't have to. You are not allowed. You are not doing some spread to the other people to make a health society. Okay, so I think that's the one base. Okay, the first question is about the technology, right? So as you know, our Korea has very strong ICT technology. So our country use that technology for preventing the spread, and also to find out the infected person's the movement, to find out the close contact person. So we want to protect some people from the infected person by using the ICT technology. So as you know, smartphone. I think most of Indonesian also has a smartphone, right? So if you make a very similar infrastructure or similar method using the ICT, then it will reduce the number of infected person by blocking them to the health people. Maybe your professor or any research team can get some idea from my this materials. You can
absolutely, Professor. Yes. Yeah, absolutely. Yeah.
Okay, sure. Okay, thank you.
Thank you so much. It helps me a lot.
Okay,
Thank you so
great. Thank you.
Yeah.
All right, thank you, Bu Desi. Is there any other question from anyone else? Anybody else?
May I? Okay. So first of all, thank you, Professor Kim, for the presentation that you have been giving us earlier. I would like to ask, from what I see in your presentation, I see that companies such as Never and Kakao, is it?
Yeah.
Yeah. they immediately create systems and application that will help in the contact tracing process. So I would like to ask whether this program actually have a full support from the government, for example, in fundings or in providing experts, or does this come from the company itself? So like, is it the initiative of the company itself? That's my
Well, I think the initiation is by the government, and government also funded that activities to develop these several kinds of app and something like that. But some of the methods are actually company generated, so they have something is free. So the Neighbor and Kakao has some like responsibility for supporting the Korean community. So that, you know, when they support this one as a free base, but it will actually help their business in the future.
I see.
So yeah, so actually two ways. One is a government funded, the other one is company oriented. Okay, generate. Okay. But I don't know how much they paid, but it's a secret. Okay.
Understood. Thank you, Professor.
Yeah.
All right, thank you. There's a question from Hassan. What if most of the population don't have easy access to the internet?
You mean? Oh, I'm sorry.
There's a question in the chat from
okay.
Hassan.
Oh, okay, I see. Well, maybe so I don't know if someone is not available for accessing the internet, then well, actually, they're just regular phone, like a text message. Actually, the message from the local office is sent by the text message. Also, with the Kakao. Kakao is based on the smartphone, but general text message is only for general phone, not smartphone, regular phone. Okay. And so government send a text message with the SNS. Well, I think everybody has a phone, but the other one is our TV. Okay, so CDC, our CDC broadcast this kind of guideline and some information about the so what happening in the local district at the news. And also on the some bottom screen of the TV. So maybe I think most of people are accessible for the TV station. And so I think that's the one way. Okay. Yeah.
All right. Thank you for the questions. And once again, thank you, Professor Kim Jae-seok, for the talk.
Yeah.
We're going to continue to our next speaker. So allow me to introduce Professor Lim Shin-il. Professor Lim, 안녕하세요. Lim Shin-il has been teaching in Seogyang University since 1995, researching areas in analog and mixed mode of IC design for communication, consumer, and sensor application. He was the chair of Technical Programming Committee International SOC Conference in 2009, and also the general chair for 2011. So we welcome you, Professor Lim Shin-il, to deliver your talk called Bioelectronic Technologies for Increasing the Quality of Life. We're listening.
Okay, thank you for your kind introduction. Can you show the slide?
Yeah, we can see it, Prof.
Yes, clear.
Oh, let me check. Can you see my slide?
잘 보입니다. 예.
네. Okay. 하겠습니다. 네. Okay, good morning, ladies and gentlemen. Welcome, everybody. My name is Chin-Il Lim, professor of Seogyung University in Seoul, Korea. It's my pleasure and honor to see you online and to share the recent technical trend of bioelectronics. Today, I'll talk about the bioelectronics technologies for increasing the quality of life. This is the outline of my talk. After brief introduction, I'll talk about 3 categories of bioelectronics technology. I'm going to start with some techniques on the biopotential signal detection. I will review what kind of biopotential signals are existed from the body and what kind of requirements are needed for the detecting circuit and so on. And then I'll take a brief look at some state-of-art research of implantable devices, such as pacemaker and deep brain stimulation devices. After that, I briefly introduce biochemical sensor chip capable of performing DNA sequencing. This technique is not matured yet, but enabling genomic personalized medicine in near future informed by an individual DNA. And finally, summarize my talk. Basically, I've been working on implementing and designing semiconductor chip for the interface circuit of these bio-related devices. But in this talk, I will exclude anything related to the circuit design technique, and I will focus on introducing technical concept, the principle of bioelectronics technology, and the requirements for implementation. This slide shows the cost of healthcare in some developed country. As you can see, the cost of healthcare is rapidly increased with the general process of treatment. As the human lifespans and the elderly people increase, the medical cost by chronic disease is also increased. WHO reported that over the last 40 years, the number of obese people has tripled. In the European region, for example, 1/3 of 11-year-old boys and girls are overweighted. This obesity causes many chronic diseases and make the quality of life worse. Populations are aging throughout the world. As you can see, the population over 65 is larger than the population under 5 globally. Korea also enters the age of aging. Korea is now declining birth rate and increasing the aging population rapidly. According to the Deloitte report, global healthcare spending is increasing at an annual rate of 4.1% between 2017 and 2021. They also forecasted that healthcare cost will be almost the same as the national one-year budget in the year of 2030. We are now living in the new wave of AI, IoT, and big data. By gathering the body signal regularly and continuously from handheld devices and also wearable devices, and by acquiring individual genomic information through small DNA sensor, biosensors, artificial intelligence with big data can predict individual outbreak of lines outbreak of illness and can inform us about the personalized treatment. If your smartwatch detect your body signal, such as pulse rate and oxygen saturation rate, then detected big data goes into Apple server or Google Android server and filed up for a long time as a form of big data. AI can tell you customized and personalized information to you. People are looking for increasing their efficiency of healthcare because it's costing too much. So people can continuously looking for a new way to improve their existing healthcare with low cost and in a convenient and comfortable way. Fortunately, healthcare technology, including bioelectronics, AI with big data, are expected to favor new version of personalized and predictive healthcare with low cost. Since Professor Kim already talked about the AI-based diagnostic kit and AI-based therapeutic drug development, I will focus on the bioelectronics technologies. This slide shows the various body signals that can be detected from the body. For a little bit of background, I will start with electrophysiology. It's very difficult terminology. It turns out that most biological processes involve the flow of ions across cellular membranes. The human body is largely on the ionic system. Ions are charged particles, and therefore they generate electric field. I, as an electrical engineer, know how to measure electric field, and that is really the basis of electrophysiology. Now, if the ions move in the space, then they create current, and therefore they also create magnetic field. We should also be able to measure magnetic field. Predominantly, electrophysiology is focused on the external measurement. You can put electrodes on the surface of body and get rich information about the electrical function of a human body. We can also certainly do electrophysiology inside the body, but obviously it's more than invasive, and we only do this in very specialized cases. It turns out when you are measuring electrophysiology from external to the body, we are not measuring individual cells, we are measuring populations of millions of cells at once. There's a bunch of different types of electrophysiology measurement we can take. There is an electrocardiograms, ECG. This is electrical activity of heart. There is a EEG of the brain, EMG of the muscle, EOG of the eye, EGG of the gut, and so on. GSR is for skin conductance. BPM is the body blood pressure. PPG measures pulse and pulse rate by using LED or photodiode. Also measures oxygen saturation rate. Voices and images are also biosignal, but not in the range of biopotential signal. This slide shows the typical block diagram for biopotential detection system. Left side is energy source. It could be a harvested DC source from vibration or RF signal, or a DC converter with LDO. But anyhow, it provides the energy source for the device. In the right side, we can have data telemetry, which is used to control the device and extract data. Also, we have a user interface and data storage devices. In the center, body signal can be detected by transducers or sensors, which generated electrical signals such as voltage, current, resistance, and charge. And this detected electrical signal is amplified, filtered, and AD converted to signal processing for data analysis and system control. These measurement block usually implemented with a CMOS chip. Electroencephalogram, mean EEG, electrocardiogram ECG, and the electromyogram EMG waves are microvolt range signals, but have different amplitude and different frequency ranges as shown in this slide. ECG signal, we can see that voltage amplitude range from microvolt to maybe a couple of millivolts, and the bandwidth goes to maybe 250. You might think this is very easy to design since we design things at gigahertz. Designing something for 250 hertz of bandwidth is trivial, and you can think that it's easy to design low bandwidth things, but there are some difficulties to implement. First of all, of course, there is a noise. In fact, signal amplitude are pretty low, especially when we get the EEG kind of territory. Noise level is slightly larger than the EEG signal. We have flicker noise too. It's just from the CMOS transistor. We also have electrode offset voltages in low frequency area. They are basically DC, but they have perhaps a little bit slowly varying frequency contents. And we also have 50 or 60 hertz interference. This makes the whole space a little challenging. Again, you can see that EMG has the frequency range starting from 200 hertz up to 500 hertz. If you look at the EEG signals, the frequency can start as low as 0.5 hertz, and the signal frequency goes up to 200 hertz. To achieve signal extraction under these circumstances, front end, I mean the instrument amplifier, is needed with a high input impedance, high CMRR, common mode rejection ratio, and high pass filter characteristics for edge coupling and DC offset removing. And for system related issue, low noise, small size, and reconfigurability in gain and bandwidth for different biopotential signals are required. Furthermore, low power consumption is necessary to achieve long-term power autonomy. Multiple physiological signals can be supported in a chip. For example, in the previous slide, since the circuit blocks for EEG, ECG, and EMG are almost the same, they can share some same hardware, but The gain and bandwidths are configured by application control. This chip implementation can reduce power consumption, chip area, and hardware cost. Handheld device such as cell phone can have optional devices for biosignal detection. This bioprocessor in cell phone can detect ECG signals, PPG, and body impedance, skin temperature, body temperature, and blood pressure. Wearable electronics has become mainstream, enabling personal healthcare technology in the form of patch, wristband, and smartwatches, making a reliable and sustainable measurement in the outside of traditional clinical setting is a real challenge. Wearable healthcare is not a new word. If you look around, you'll find tons of wearables in different form factors. For example, earbud, such as AirPod of Apple, patches, belt, or shoes. They can measure variety health parameters in your daily life. So from a market perspective, the wearable healthcare market is expected to reach more than $41 billion in this year. As I already mentioned, populations are aging throughout the world. The cost of healthcare keeps rising, right? So people are continuously looking for new ways to improve their existing healthcare with low cost and in a convenient and comfortable way. Wearable sensor can be a good solution for this. Sensor on the body can measure signals continuously, empower you to change your bad behavior and lifestyle to live healthier. Furthermore, they can manage disease and health conditions and reduce the number of days patients spend in the hospital. So wearable healthcare will link to the concept of outpatient monitoring or home healthcare. It is benefited from the advancement in AI and big data and IoT. The block of wearable devices include the blocks of a biopotential measurement system in the previous slide, but wearable devices have various energy harvesting source for powering and also have a wireless interface to communicate with server. This is the basic function for IoT applications. Multimode physiological and weak biopotential signals can be recorded with the help of one system chip that guarantees the robust and precise signal processing, even in the many difficulties such as noise, offset, and interference, etc. This high-level chip integration reduces the complexity of PCB, amount of components, power consumption, and the system cost of medical devices. And this bioelectronics technology enables to implement wearable and implantable miniaturized medical devices. Bioelectronics technology, including molecular biosensor chip, paved the way to perform predictive, preventive, and personalized treatment, and hence to increase the quality of life. Okay, let's move on to implantable devices. Here, I will show you some examples. First one is the pacemaker, which can regulate heartbeat. The second example is used for spinal cord stimulation. This can be used to treat patients that suffer from chronic pain who cannot be treated by traditional methods. The middle one is a cochlear implant, which has been very successful. The first one in the left bottom corner is a visual processes. This technology is not matured yet, but it could attract a lot of attention because it could really help people who are blind. They can be see again. Last in this slide is the deep brain stimulation device. It includes a metal can, which houses all the electronics and battery and reed. At the end of the reed, are the electrode, and these are responsible for interfacing with the brain. In this slide, some examples of therapy by microstimulation are displayed. Since these devices are implanted in the body, miniaturization and low power consumption are essential requirements. This is an X-ray of an implantable device. You can see that this can be implanted on the chest, and the wire for the reed is run underneath the skin and to the back of the ear and to the top of your skull, where it's possible to drill a hole and insert the electrode into a deep area of the brain. With these deep brain stimulation devices, the patient who suffer from tremor or Parkinson's disease can be relieved of their symptoms. A cardiac pacemaker is used to treat bradyarrhythmia, or heart rate is too slow, and cardiac arrest. This device monitors the heart rate, how fast it beats, and also heart rhythm, the pattern in which it beats. And it provides electrical stimulation when the heart does not beat or beat too slowly. It's typically small in size and often less than 1 ounce in weight and less than 2 inches wide. Cardiac pacing devices, pacemaker, are the almost common implantable biomedical device on the market. Several factors contribute to the success of pacemaker, among which size and battery longevity. The pacemaker system, as shown in this slide, consists of 2 components, pacing lead and pacemaker device. The pacing lead connects between the heart and the pacemaker device. It is flexible, insulated wire with an electrode tip. This tip, inserted through the vein in the heart, carries impulses from the pacemaker device to the heart and stimulating the heart to beat. Battery, PCB, and chips are sealed with the titanium can housings. Low power consumption is essential in circuit design to guarantee the minimum 10 years of operation with 1 battery. So the most transistor in the chip is operated in the sub-threshold region. Let's look at the comparison between the pacemaker and the neuromodulation device. I mean the deep brain stimulation devices. The pacemaker detects the heart information, will do the analysis in time domain to detect P, R, T signals to determine whether a bit is missed or not. If you detect a missed bit, then the stimulation will be delivered and it will trigger a heartbeat. For the neural stimulation devices, it's slightly different. The signal has to go through spectral domain analysis, like FFT operation, to extract spectral information from the deep brain. For example, we get the energy information at a given frequency band and potentially use that to close the loop for stimulation. This slide shows the simplified diagram for implantable devices that include 5 parts. For the top is the energy source. It can be a primary or a rechargeable battery, or it could be an RF power source with a supercapacitor. But anyhow, it provides the energy source to the devices. Then you have data telemetry, which is used to control the device and extract data. At the bottom is the nervous system. We have to have a way to interface with the nervous system, both for sensing and for stimulation intervention. This part is mainly different from the block diagram of biopotential measurement system in previous slide. Between them is the signal processing for data analysis and the system control, and it can be implemented in our SoC1 chip. Since the device is built in the body, it should be small and biocomfortable. Safety and stable operation are essential requirements. Okay, next topic is the biosensor. Quantitative and specific detection of biomolecular, such as DNA and proteins, have numerous applications in biomedical diagnostics and individual monitoring. DNA sensing, in particular, has broad application in genotyping, gene expression studies, biohazard detection, drug discovery, and so on. Over the past 3 decades, we have witnessed substantial progress in DNA sequencing method, leading to significant acceleration in medical research and discovery. Biochemistry sensor chip technology is pushing closer to our homes by enabling genomic personalized medicine, in which healthcare is informed by an individual DNA. There is a DNA sequence, a sequence of adenine, thymine, guanine, and cytosine determines the DNA structure. DNA is structured by the sequence of complementary chain, as shown in the left side. There we have a specific binding of adenine, thymine pair, and also guanine, cytosine pair. In general, DNA microchip is slide made of glass, a polymer material, silicon, etc. On the surface of such a chip, single-strand DNA receptor molecules, probes, are immobilized at a predefined position. These probe molecules consist of different DNA sequences, whereas a number of different techniques are known to functionalize the chip. In this figure of left, two different sites within an array are considered after the immobilization phase. Spot different single-strand DNA sequence on the different position. After that, as shown in the figure of center, the whole chip is flooded with a sample containing a target molecules. In case of complementary DNA sequence of proof and target molecules, their match lead to a hybridization as shown in the right top. If proof and target molecule mismatch, this chemical binding process does not occur as in the figure of right bottom. After a washing step, double-strand DNA is obtained only at the matching position. At the mismatch site, single-strand DNA molecules remain, and the same situation as in the initial case of left side. Since the receptor molecules are known with the label, the information where double or single-strand DNA is found at the different test site reveals the composition of the sample. Thus, the requirement contains to identify the site with double-strand DNA. In conventional systems, the target molecules are usually labeled with the fluorescent markers, and an optical image of the array chip reveals the position with the double-strand DNA. But this kind of detection system needs optical devices, which makes the system bulky, so the system slow and very expensive with large power consumption. A single sensor site consists of interdigitated gold electrode on the CMOS chip. Proof molecules are immobilized on the gold surface. The target molecule in the sample are targeted by an enzyme label. After hybridization and washing phases, a chemical substrate is applied to the chip. At the position with matching DNA strand, the enzyme label cleaves to the phosphate group and generates an electrochemically active compound. Applying simultaneously an oxidation and reduction potential to the sensor electrode, about several hundred of millivolts with respect to the on-chip reference potential, the oxidation and reduction process generates currents at the electrode. A potentiostat whose input and outputs are connected to the reference and to a counter electrode respectively, provide the difference current to the electrolyte and regulate the potential of the electrolyte to a constant value. As shown in the previous slide, the electrochemical biosensor transduced between the ions and the electrons. This is typically done by measuring electrons through the electrochemical reduction and oxidation reactions. There we have three main cases of electrochemical biosensors. This is the potentiometric. There is a potentiometric biosensor. This effectively just measure open circuit voltages. And there is an amperometric sensor, which effectively measure current, as in the previous slide. And there is an electrical-chemical impedance spectroscopy sensors that measure complex impedance. This slide shows another example of electronic sensing in biochip. The circuit measures capacitance variation due to DNA hybridization on the gold electrode, which are bio-modified by covalently attaching proofs of known sequence. This work was fabricated with the standard CMOS technology with one additional step for gold deposition. Some company like Insilixa announced the commercial product sensing with the CMOS image sensor. It was small, fast, and disposable, but there is a limited reaction applications. This biomedical technology in the form of single-use disposable chip provide performing medical diagnostics and DNA sequencing, and the use of scalable CMOS chip architecture allows radical levels of economic scaling and provide convenient new format of diagnostics and predictive and personalized medical services. Okay, with the help of bioelectronics, as I mentioned in this talk, also with the help of AI, IoT, and big data, we can change the conventional medical treatment to predictive and personalized medical services. This technique is not matured, but it rapidly developing. There are many obstacles to overcome. It's really worth challenging. Okay, here we have a summary. Multimode piezo signals, physiological and weak biopotential signals can be recorded with one system chip. High-level chip integration reduce the complexity of PCB, amount of component, power consumption, and system cost. And hence enables wearable and implantable miniaturized medical devices. These miniaturized medical devices enable people to increase the quality of life. Moreover, bioelectronic technology, including molecular biosensor chip with AI and big data, paves the way to predictive, preventive, and personalized treatment. Okay, thank you for your attention.
All right, thank you, Professor Lim Shin Il.
Yes.
That was a nice talk. It's quite important that healthcare is accessible to all citizens, regardless of their financial situation. So, healthcare can be a good alternative that is low cost. I hope Indonesia is also creating some sort of wearable healthcare sensors or an implantable device. So we're going to continue to the Q&A session with Professor. If anybody has any question, turn on your audio and video or type your question in the chat box.
I think this must be a little bit difficult in the specific area.
Hi, BINUS students, ask him whatever you want. Okay? As it's a medical science for
one question
life.
in chat room.
There's a question in the chat box. It's by Hassan. He's asking if how the implants are medically tested.
I don't know exactly, but they tested in the pod of animal first, and then a transport to the people. It takes a long time, and they spend too much cost to test the implantable devices.
How the implants are medically tested.
Sorry? How?
Does anyone else have a question?
Some message. Hi. So faculty members can ask any question, okay, for bioelectronics.
I think this was very difficult to understand because there is a very difficult word inside and a specific circuit design issue inside the talk. So it's very difficult to understand, I think. Yeah.
Yeah, I think in Indonesia, for like IoT like this for medical is not common yet. Yeah, even our research is not really in that area, I think. But this is very good, I think, for our student. Yeah, this is a new opener, eye opener for them that you can use your skill in programming using IoT. You can do something good then. Okay, any question, guys? Oh, again, Hassan has a question, Rachel.
Oh yeah, Hassan is asking if is there a risk for the chips being accessed by third-party groups?
The question is, the chip is accessing third party?
By third-party groups.
So somebody can get the data also, yeah. Not.
Yeah.
Yeah.
I don't know exactly about the questions.
Hassan, can you elaborate?
I think Hassan, maybe you can explain what you mean.
Okay. I was asking if the chips have like Bluetooth and like Wi-Fi availability so that they can send data to the sending data. Is it possible like someone can hack into a system and be able to like change the program of the chips? Because it could be dangerous if someone has like a pacemaker and then someone has access to their pacemaker that is not the medical company that made it.
Yeah, the security maybe, yeah, Prof. About the security.
I'm sorry about I cannot understand exactly about what he means or what the question is.
Okay, I think for Hassan maybe yeah, the company will make sure that will be safe. Yeah, I think also the Korean government also will make sure that will be okay. Then they will launch that. But before that, I don't think so. They will launch that kind of what you call it, IoT gadget. Yeah. I think for me, I think so. I think I don't know. Yeah, the rules need to be set, I think, by government. Right. So, Prof. Im. So, how about the Korean government, yeah, about this kind of a new thing in technology? What kind of the rules that they create or yeah, to prevent or to govern a new technology over there in Korea?
In Korea, we have an institute to guarantee the duly invented devices. It's very difficult to go through the inspections. So it takes a long time, even though it has a functional tested, but the empirical testing to the body, to the human, and also animals, it will be take a long time to test the devices to the market, and also there is there is a cost too much during the test, so it's very it's very expensive when it comes out to the market, and also it takes a long time, minimum 5 years or 10 years to spread in the market. Okay.
Thank you, Prof.
Yeah.
Okay. Any other question, guys?
Anything is okay. Hi, BINUSian students, ask him whatever you want.
Hey guys, any question? Just ask any question is okay. Not necessary about this topic. Yeah, maybe around other technology in Korea if you want to know more. We have a 4 or 5 professor here, so you can ask them.
질문이 없는가?
Okay.
교수님, 너무 수고 많으셨어요. 질문이 너무 어려워서 질문이 없는가 봐요. 예.
Okay.
임순희 교수님 너무 고맙습니다. 예, 감사합니다.
Thank you. There's another question. Another question, Rachel.
Darren, from Darren.
Yeah.
Darren, you would, okay, I'll just read it. Why does Korea have such a huge market in the report community?
How?
Why does Korea have such a huge market in the esports community?
I don't know exactly about that.
이거 보면요.
My son always enjoy games.
It's very good in esports there.
Such a huge market in the report community.
In the esport.
Esport.
And how does it affect the development of technology?
Okay. Yeah.
Well, actually, we don't know why, but the most of Korean young people like the game, game using a smartphone, and then so they are actually like so that's another problem in our it's education environments for the parents. But anyway, so I think so that's so another thing is our Korea has a big company for creating the game, e-game, right? Some Renigi, or I don't know the exact name, but so it's a big industry for the e-game. So that's now the China is catching our country. However, well, couple of our game industry, game companies are having a big money, making a big money in this one. Okay.
All right, thank you, Darren, for the question. Is there anybody else with another question to any professors? Oh, from Leon. Sorry, this is a bit unrelated. I'm only a little bit curious. Has quantum computers got to a point where realistic applications are possible in Korea? And what are the potential applications of quantum computers?
Quantum computers. One of the application area is the weather reporting, and also AI, and then it treat some big datas. I don't know exactly about that.
교수님, could you show us about the biocomputers in the Korean situations, how to develop the biocomputers based on biotechnology? Okay.
Biocomputer?
Based on the bioelectronics, you can develop the biocomputer. Okay. 김 교수님 들어오셨네요?
Yeah. Some students want to have some email address, so I put my email address on the chatting window.
Thank you, Prof.
Yeah,
Thank
okay.
Yeah,
Okay. 김
yeah, that's
교수님,
a good issue.
코멘트 있으시면 좀 해주시면. Daniel Min or Professor Jessica Kim, could you give us some comments for this topic, so bioelectronics, and how,
I think,
how can you apply this bioelectronics to protect the coronavirus?
I think it is a very interesting topic. I think that a simulation model before exploring with a physical, circuit model, so simulating, biological integration of a biological system and electronic system. It takes, so much time to test with the real animals or human body. So preliminary stages to process. That's more difficult.
Okay. Any other?
Any other questions? No questions?
You're silent.
Yeah.
Yeah, we can wrap up now, right? Yeah.
All right. Okay, that's all for today. We're going to end today's session. I would like to thank Pak Raymond Bahana, Mr. Jude Martinez, Bu Nurul, Professor Daniel Min, Professor Cho Ho Kang, Professor Kim Jae-sok, and Professor Lim Shin-il for today's session, and all participants who are listening and participating. We hope that today's talks have been informative and beneficial for all of us. Tomorrow, we're going to continue our discussion. So please join us on the second day of this webinar at the same time from 9 a.m. to 12 p.m. See you. Thank you and have a good day, everyone.
Thank you.
감사합니다.
Thank you. Bye.
Jangan harap sehat.
Bye.
Rachel, thank you very much.
Thank you.
Okay.
Take a picture. Take a picture.
Thank you very much for your presentation.